Hello YouTube, I Fix It All here, Team I Fix It All. So my neighbor had a emergency here a few evenings ago and had me flare out some copper tubing because this copper tubing failed on him and it's kinked up in a few areas. Kinked up such that I can't easily roll it up and store it. It is a decent long section of copper tubing, but what do you do with it? I know you'd say, well, throw it away. Not my style. It's just there's a lot of copper here. At least make use of some of it. So let's do that. Be right back. Let me get my tubing cutter here and I'll show you. What's my length I want? Let me see. Got a little jig here. It's good clean copper on the inside too. Tear it in. Get out of here. Alright. Let's see what we got. We'll just clean the end out with the pokey bit on the tubing cutter. Put it in the vise here. Get the hacksaw. Yep. Straighten it out a little bit. Let me get my microphone. This will be the first time I've added a microphone to the phone after the video. Looks like my microphone is microphoning. Clip this on. Okay. Hope it doesn't go mute. And right there should be good. So I've made me a cut in the tubing. I'd say just a little over or under halfway. But I'm focused on the area from here to the left. I want to make it flat. And I'm going to crush it. Need a hammer. Run it on the wire wheel. Good enough, good enough, good enough. Does this look familiar to anyone? Let me try this. Does this look familiar? Or how about that? See, that's all they really do when they make lugs, is they use tubing and it's calibrated. It's 10. This is a tin coated lug, copper, burgundy. Let me see what size. This is a 2 gauge. Yep. Two NT14-FX. So it's flex number 2. All right. So here's what we've done. We've effectively created, for future use, several lugs that can be drilled and either be 2-hole lugs or single-hole lugs, or whatever you desire. And you can add them to your bin of lugs. Yes, that's a lug, believe it or not. That's a tap, where you can add multiple wires. That's a temporary tap, where you can tap through the insulation to temporarily splice in a cable if you want to bypass and rewire it somewhere. Lots of lugs here. H-tap lugs, 2-hole lugs. There's another H-tap. 90-degree lugs. So what I'll do, one day, I might need these for something. So when you think about throwing stuff away, start thinking about how to repurpose part of it as well. I have so much copper here, I could keep making those lugs, but I've got plenty. But there's something else you can do with it too. You can make bus bars, or if you want to join 2 12-volt batteries up. But how many amps is it worth? Let's look it up. There's a website called copper.org. And if you go there, there is a section dedicated to DC copper bus bar ampacities. And you start studying the tables and you start to understand what they're trying to explain. But over here it says number of bars, what is your thickness, what is your width, and then that'll be the cross-sectional area in circular millimeters. And then there's the ampacity rating. How many amps can you handle per note A1, or how many amps can you handle versus note B2. In one instance it says it's worth 154 amps, in another 152. So number of bars, obviously I'm at 1 bar, which is 1 lug, 1 tang. And it says thickness, 1/8. Well, this is not 1/8 inch thick. This is like 0.7. So what is 1/8? 1 divided by 8 should be 0.125, I think. Yeah, 0.125. So 0.125. And my thickness I gotta put you all on a broom handle here. So my thickness is 0.55. 0.055. Yeah, so 0.055 divided by 0.125 is about 44%. So this is as far as a 1/8 inch copper bus bar. If I just wanted to willy-nilly it and just guesstimate, if that's 1/8, 0.125, and I already said this is 0.055, then I'll just use my lower amperage and say this copper lug is capable of handling, oh, we got to go by the width. And the width is 3/4 of an inch. What is my width? What is my width? Let's just call it. It's a little over 1/2 inch. Since it's a little over half, but under 3/4, then my bus bar is pointer. My bus bar is somewhere in between 1/2 and 3/4. Maybe I should zoom for you. Zoom plus. Yeah. So I'm somewhere in between 1/2 and 3/4. I'm going to use the lower amperage. Oops, I clicked something. Use the lower amperage, column B2. And I'm going to be the difference between 152 and 212. Let's just say 200 amps. My lug I just made is going to be about 44% of 200 amps. So that's, quick math tells me that's 88. But if my middle ground between a 1/2 inch wide bar and 3/4 inch bar is the difference of 152 to 212. Let's just do that. 152. Where's my plus? Light's glaring. Plus 152 plus 212 equals that. Divided by 2 is 182 amps times 0.44 times 0.44, 80 amps. This lug should be able to handle 80 amps. But what's interesting is, guys, if your copper bus bar is laying in this orientation, flat, and it lives in a piece of equipment that's the way it's oriented, it can produce less amperage than if it is mounted in a device where it lives the rest of its life in this orientation. And that's what note A1 or note B2 is about. In this orientation, you can allow for more amperage on this lug than if it is like this. If we scroll down to note A1, A1 is the higher copper rating, the higher amperage rating. We scroll down to note A1. Note A1 says, the ampacity rating is based on 30 degrees C rise above 40 degrees C ambient. The bars are run with their long axis vertical. That being the long axis being vertical. The spacing between the bars, let's say you had multiple bars side by side, that's called bus duct or bus work. The spacing between the bars is equal to or more than the thickness of the bars are run in a horizontal plane. Okay, so the long axis is vertical. So if a lug lives its life in this orientation, then you can use column A1. If it lives its life like that, you have to use note B2. But right there's that's a 80 amp lug. Life is good. All right, guys, see ya. Bye.